let us take the third reaction under the base catalyzed condensation. Third reaction is a benzoin condensation. The OIN, it is a condensation reaction. The OIN represents a carbonyl group attached to a hydroxy function. This particular function is said to be a OIN function. So, benzaldehyde is giving this type of function containing compound, therefore, it is known as benzoin. Once again, just like aldol is not a scientist name, the benzoin is also not scientist. Cannizzaro is a name reaction, Perkin condensation, several scientist names we have name reactions. Here, the benzoin is a compound formed in the benzaldehyde. So, therefore, this is named as a benzoin condensation. So, the conditions required in this reaction, which compounds undergo means only aromatic aldehydes. Aromatic aldehyde means, once again it is very clear that no alpha hydrogens and they should be aldehydes. Second one, the base is used is KCN or sodium cyanide. You can also say a cyanide minus is the base. Both K and Na belongs to alkali metal, therefore, you can say alkali metal cyanide. Alkali metal cyanide. HCN, hydrocyanic acid, is a weak acid. So, cyanide minus is a strong base. So, therefore, logically it is base catalyzed, means what is the base means it need not to be a sodium hydroxide, it can be a cyanide minus. So, the reaction is here cyanide catalyzed reaction. What happens means an aromatic aldehyde condenses, in fact, two benzaldehydes will condense. Many times in the condensation, head to tail type of condensation will be in general rule, but here two benzaldehydes will condense head to head and give this type of the function containing, that is a CO attached to the OH. So, you have a compound like this, a benzaldehyde and a benzaldehyde. In fact, if the hydrogen, if I write like here, one can say that this is one benzaldehyde, that is one benzaldehyde, or the benzaldehyde hydrogen is added there, the rest of the benzaldehyde. You can show something like two benzaldehydes are joined like this, but literally speaking, if you see the mechanism, this type of two benzaldehydes coming opposite and then joining, breaking into one compound and the rest hydrogen, that hydrogen is added there, that is not the real correct one. See the mechanism how it is taking place. A cyanide minus is catalyzing, the product called benzoin. Like that we have some common names. If a furan aldehyde is taken, furan will have an aldehyde on the second position, 2-furan aldehyde, or it is also called furfural, a common name is there, furfural. Formylated fural is called furfural. This furfural will undergo this reaction to give the furan with a furan containing a OIN function. OIN means CHOH and again a furan. This is called furoin. So, benzaldehyde gave benzoin, furan aldehyde will give furoin, and so on. Different types of the compounds you can have this type of reaction. This is an aldehyde containing a OCH3 at the para position. If aldehyde is not there, benzene with OCH3 is called anisole. The anisole with aldehyde is called anisoaldehyde, and that too there is para relation, therefore para anisoaldehyde. Para anisoaldehyde will give the, when cyanide treated, it gives the, again you will get a anisoin. Anisole means a OCH3 group should be there. This OCH3 is there and aldehyde should be opposite to each other, that is para. So, here if this is the one, the fourth position OCH3 will be there. Again with reference to this one, OCH3 will be at the para position. This is called as a para anisoin. Para anisoin. Anisaldehyde will give anisoin. Corresponding OINs are formed, therefore, the reaction is called benzoin condensation. So, in this reaction. Cyanide is the catalyst. The cyanide is not used up, you see in there you don't find cyanide. So, definitely cyanide is working as only catalyst, and the cyanide, as I said, HCN is weak acid, cyanide minus is a strong base. So, in the presence of strong base, the reaction taking place and the two molecules joins, except in the Cannizzaro reaction. See, the one carbonyl, another carbonyl, CC bond, a new CC bond is generated, molecules will join up to become a bigger molecule is formed. So, it is a condensation in which two molecules join, no doubt, but not by eliminating the water, just they two joined. And let us see the exactly how the mechanism is bringing this type of the O-in formation. Let us observe. So, let us see the how the benzoin condensation taking place mechanism. Let us see. So, I will take benzaldehyde. The benzaldehyde is being attacked by the cyanide minus. So, cyanide is a minus, so it attacks when the carbonyl group polarizes into minus and plus. On the plus, the cyanide minus is attacking, it is justified. So, you get a phenyl with a, let us write cyanide down and put the hydrogen that side. O will become a O minus. Now, here let us have a small logic here. Imagine that these two are both the carbons are there, and this has one hydrogen, this carbon also has one hydrogen. Just imagine for a minute, there are two carbons, first carbon has one hydrogen, second carbon is also one hydrogen. The cyanide is pulling because of the electronegativity of the nitrogen, it is pulling, the triple bond opens many times. So, therefore, it is a very good strong electron withdrawing group, minus I group. So, because of this strong electron withdrawing power, this hydrogen, the carbon hydrogen electrons also will be pulled. Hydrogen is liable to given out as a H plus. The H plus giving substances are called acidic. Now, there is a carbon, there also one hydrogen is there. Even that pulls because this carbon pulls and then O carbon pulls. Both hydrogens will have acidic, but which hydrogen will have more acidic? First one. But here what happened is the first one is not given, but the second one is already given, as if this H is you have shown as a detached. So, that is logically slightly a mistake has crept in. So, therefore, to set right immediately, naturally what happened, the H plus will be detached and that H plus will be exchanged to here. So, that the O gets one hydrogen. So, the carbon however gets a negative charge. This is called what? A carb anion. Once again the anion is formed. This is what the RD step or slow step. So, the minus attacking on the plus is a fast step, you convinced this one. Now, here the H plus shifting from here to there becomes a C minus. O minus is quite a stable one. So, therefore, this will not be this one again, anyhow it is already fast step. So, this is the slow step. When once the anion comes, the anion formation is the slow step. Once the anion is formed, there is another benzaldehyde waiting to receive that the anion. So, it polarizes into minus and plus. On the plus, this minus will attack. Okay. So, this is what very important step, not RD step. RD step is no doubt kinetically that is very important, that is rate determining step. But minus attacking on the plus, what minus? Carbanion attacking on the plus, what plus? Carbocation. The C plus C minus joining to creating a new synthetic CC bond is somewhat very much important for the synthetic organic chemists. So, new bond, which bond is formed means, so this benzaldehyde carbon, that benzaldehyde carbon is going to join up now. Okay, let me write this benzaldehyde first with C with O minus and then one hanging hydrogen, then go to this carbon, a cyanide is there, top OH is there and then another phenyl is there. This is what you get now. Okay. Now, again the logic if you apply, the cyanide is a strong electron withdrawing group. If imagine that there is a OH, there is a two OHs are there, which OH hydrogen will be more acidic? again the first carbon OH should be the more acidic. But what happened here, the first carbon OH is not given, second carbon OH is already given, that is against to the natural the phenomena. So, therefore, immediately this step should be rectified, that wrong step, just like when we are walking, sometimes your step may go wrong. Then what you do, what you have to do is, you have to step this side, it is slightly to balance the other side, like that. In the course of action, sometimes the molecule also went wrong, for example. So, then what is the next step means, it should be rectified. So, here a mistake has crept in, what is that? So, the strong OH is not given, but the weak OH is given, that is wrong. So, therefore, let us set right, this proton is changed. So, H plus shift will be there, okay, right. So, if you understand the logic, I think the mechanism will become automatical flow will come to you. So, the proton will be shifted here. So, you will get a O will become OH and this side will become O minus, because strong base will donate, already donated, now it is set right. You may ask what is the great difference between that and this, are both are OHs, but it comes a difference, see that. If the O minus, now it comes back, cyanide minus has got a 2 ambiguity containing behavior. What is that? It is a strong base to enter, okay. While going, it is also a weak base, therefore it goes out. So, cyanide has got an entry is easy, outgoing also very easy. Cyanide is one of the best outgoing group also. Entry is also is because it is a strong nucleophile. So, cyanide has got an outgoing property, therefore cyanide is left. So, therefore, minus of cyanide minus, that gives a final answer for you. One side a carbonyl group, one side an alcohol, this side let us write an alcohol. So, this side will become alcohol, that side you will get a carbonyl and one hydrogen will be here. So, this is what your benzoin. A benzoin contains what? A carbonyl group attached to an hydroxy group. It is a alpha hydroxy carbonyl compound, in fact called as a oin. So, benzaldehyde is gave this one, so benzoin. So, in this there are 2-3 important points to note. One is the minus attacking on the plus will develop this CC bond. So, in this whole mechanism, this point carbanion attacking on the carbocation is there, which is there in aldol condensation, which will be there in the Perkin condensation next coming, and so many aldol condensation, similar type of reactions, this carbanion attacking on the carbocation will be there. But very few, like Cannizzaro reaction we have seen, there is no carbon-carbon bond formation. Parallel reaction, one undergoes oxidation, one undergoes reduction. Now, here that conceptual, the point is there, carbanion attacking on the carbocation, a new synthetic bond CC is formed. And as usual, what will be the rate determining step means, minus formation will be the slow step. This is the early step. Once the anion comes, it cannot be delayed. So, anion attacking on the plus is a 0 minutes time. So, these are all proton exchanges, that is the final touch-ups. But the main point you remember, one benzaldehyde being attacked by the cyanide, that is the step 1. After that cyanide, the cyanide will be going on doing some magic here. Cyanide withdrawing, so the proton exchanges, a carbanion is formed. That attacks again a proton exchanges, and then when O minus comes, cyanide is leaving. So, you get a hydroxy carbonyl compound, that is the mechanism of this benzoin condensation, right.